Presenting our work a Whac-A-Mole dilemma, shortcuts come in multiples where mitigating one amplifies others. We studied the problem of shortcuts, the unintended decision rules in machine learning models, such as background shortcut in object recognition. While previous works only assume a single shortcut in the dataset, we study a real-world problem where multiple shortcuts exist, such as background and core-crane object shortcuts in ImageNet. To this end, we construct two new multi-shortcut benchmarks, UrbanCars and a new multi-shortcut benchmark for ImageNet. Especially, we found a new watermark shortcut and created the ImageNet-W dataset. The watermark shortcut is not only pervasively found in 32 models, including foundation models such as CLIP, but also causes huge accuracy drop. Through a comprehensive benchmark on 26 methods, we found that multi-shortcut mitigation resembles a Whac-A-Mole game. Mitigating one shortcut amplifies the reliance on others. To tackle this problem, we propose Last Layer Ensemble, a new method to mitigate multiple shortcuts jointly without a Whac-A-Mole dilemma. Here's a more detailed introduction. When studying the shortcut learning problem, existing works make a tenuous assumption that only a single shortcut exists. For instance, the value used the Waterbird's dataset only benchmarks the mitigation of the background shortcut. However, this assumption oversimplifies the real-world problem where multiple shortcuts exist. For example, on ImageNet, models classify the waterable images based on two shortcuts, background and core-crane object. To this end, we ask a new research question: can existing methods overcome multiple shortcuts? To answer this question, we construct the UrbanCars dataset, a new multi-shortcut dataset with two shortcuts, background and core-crane object. It is a semi-synthetic dataset to study multi-shortcut learning under the controlled setting, which has many advantages. For example, two shortcuts are commonly seen in the real-world image datasets. The correlation strength of each shortcut queue is controllable, and we can easily obtain accurate shortcut labels, which enables us to benchmark a broader range of methods, such as methods using shortcut labels for mitigation. In more details, the task is to classify the main object car into two categories, urban car and country car. Both background and core-crane object shortcuts are also in urban and country categories, which are spuriously correlated with the main object car. For example, for the urban car images, urban background and urban core-crane objects are more common in the training data. The common and uncommon background and core-crane object categories make the training set imbalanced, where models can learn either one or both of the shortcuts. We further study shortcuts in the large-scale and real-world ImageNet dataset. For texture and background shortcuts, we use the existing stylized ImageNet and the ImageNet-9 respectively. Furthermore, we additionally discover a new watermark shortcut and construct ImageNet-W, a new evaluation set to expose models' watermark shortcut reliance. Along with texture and background, this forms a comprehensive suite to evaluate reliance on multiple naturally occurring shortcuts in ImageNet. In the training set of ImageNet, we found that many cartoon class images contain watermark written in Chinese characters, which are used by models to predict the cartoon class. In the validation set, none of the cartoon class images contain the watermark, which explains the poor performance of many models for the cartoon class. Based on this finding, we construct the ImageNet watermark over ImageNet-W, which is a new test set to evaluate watermark shortcut reliance. Concretely, we overlay transparent watermark written in 捷径, where 捷径 means shortcut in Chinese. For cartoon class images, adding watermark alters models' predictions from wrong predictions to cartoon. Similarly, for non-cartoon class images, adding watermark makes the model predict cartoon incorrectly by focusing on the watermark region. We found the pervasive watermark shortcut reliance in 32 models, regardless of architectures and sizes, training data, augmentation and regularization, supervision, or transfer learning method, including self-supervised and foundation models such as MOCO and SWAG. All models achieve large accuracy drop from ImageNet to ImageNet-W, which is up to 26.7% and 10.7% on average. Interestingly, CLIP with zero-shot transfer, meaning that it is not trained on ImageNet, also shows watermark shortcut reliance. To study this, we look into Lion dataset, a public dataset for CLIP pre-training, which contains 400 million to 2 billion image text pairs. We find that many cartoon images in Lion also contain watermarks. This is one of the first real-world examples showing that billion-scale datasets for foundation model pre-training can also contain shortcut. Regarding the evaluation metric of each shortcut, we use accuracy gap between in-distribution and out-distribution data. On UrbanCars, to measure the background shortcut reliance, we use BG gap, which is the accuracy drop to uncommon background images, and similarly we use COOBJ gap for core-crane object shortcut. On ImageNet, we use SN gap, NN gap, and NW gap to measure the texture, background, and our newly discovered watermark shortcut in ImageNet, respectively. We benchmark a wide range of methods for multi-shortcut mitigation. First, we test empirical risk minimization with URM, which is the baseline model with standard supervised training. Then we comprehensively benchmark 18 shortcut mitigation methods in 4 categories, including standard augmentation and regularization like CVPR, targeted augmentations like style transfer, using shortcut labels like sub-G, and inferring pseudo shortcut labels such as JTT. We find that all 4 categories of methods, although can mitigate the shortcut by closing the accuracy gap relative to the URM baseline, actually amplify other shortcuts by enlarging the accuracy gap compared to URM. Here we use the mole with a hammer icon to denote the shortcut mitigation and the mole icon to denote shortcut amplification. We combine these 2 icons together to denote a method mitigating one shortcut but amplifying others. In the first category of methods, CVPR amplifies the background shortcut by achieving almost triple the BG gap. Methods using targeted augmentations, although mitigate the targeted shortcut, amplifies the untargeted shortcut. For example, style transfer for mitigating the texture shortcut amplifies the watermark by 1.2 times because of the amplified shape of watermark in style transfer augmentation. Methods using shortcut labels, although mitigate the labeled shortcut, amplify the unlabeled one. For instance, sub-G using background labels amplifies the COBJ gap by 3.24 times. Methods inferring pseudo shortcut labels, although mitigated the inferred shortcut, amplify the missed shortcut. For example, yield achieves 2.21 times COBJ gap. To summarize our comprehensive evaluation on 2 benchmarks, we find that multi-shortcut mitigation resembles a Whac-A-Mole game, that is, mitigating one shortcut amplifies the reliance on others. How to address this problem? A straightforward way is to use multiple targeted augmentations jointly. We find that this method is suboptimal due to incompatible shortcut augmentation pairs, such as watermark and texture augmentation. To this end, we propose Last Layer Ensemble method, which trains an ensemble of last classification layers on top of a feature extractor, where each layer is trained only with one type of augmentation that simulates a type of distributional shift. When making predictions, we use the predicted distributional shift to aggregate the predictions from multiple last layers. For example, when the input image contains the watermark, the predicted watermark distributional shift will upweight the predictions from the classifier trained with watermark augmentation, reducing the impact of incompatible augmentations. Finally, check out our GitHub repo for our project's code and 2 new datasets.